Huh?
No, he did that once, but it didn't work.
It usually brings it back.
It didn't work.
He got a new one though at the end of the year, so he should have it.
Maybe that's why it didn't really happen.
At the end of the year, it didn't happen. Well, you guys you wouldn't have even known. It was after AP. Okay, here we go. So let's go ahead and try this. So let's look at pictures of limits here. Okay. And you guys, likely your test is probably going to be all multiple choice. Okay. I just want to know that you can prove to me that you can do some calc. You learned something last year. Okay. Okay, it says we're supposed to use the graph to determine each limit. We could do it analytically, which means, remember, we factor and cancel stuff out. Okay. So it says x as it approaches 0. So if you're looking as it approaches 0 from the left and the right, what is the y value going to there? It's at -2. Okay. And then this one here, it's asking us as it approaches -1. Let me erase because I'm kind of on the top of -1 there. Okay, so if I look at -1, the x value of -1, where does it look like y is approaching from both sides? It looks like -3. Okay. Everybody good on number 5? Again, I'm just pulling from the hints. That's right. So this would be your Chromebooks. It's the chapter 1 page of the review exercises, the first page. All right, looking at this one. Oh, I didn't grab the little guys from the bottom, huh? I missed half the problem. Let's see. Chapter 1, what was their limit supposed to approach? I missed my copy and paste. 2 and 0. So the limit as x approaches 2 of g of x, and then the other one was the limit as x approaches 0 of g. You'll get used to my handwriting, those of you that haven't had me. That says limit. Okay. All right. We're looking. Okay. What's concerning about the graph that we have to be careful of? How is it scaled? By 2's, right? This is 2, 4, 6, 8. So if limit as it approaches 2 is that asymptote, right? So is there a limit? No. So that's a does not exist, a DNE, right? Okay. All right. What about as it approaches 0? Is there a limit as it approaches 0? Yeah, what's the limit as it approaches 0?
0.
Looks like 0 to me. Okay. All right, all good with 6? Yeah? Okay. All right. This one wants us to do it analytically, meaning we have to use algebra. Okay. What are we going to do first?
Plug in.
Okay, if I plug in, what happens to the denominator?
It's 0.
It's 0. Okay, so we want to do something more than just plug in. So what else can we do? Factor. So the limit as x approaches -2 of t plus 2. Sorry, it's t, not x. What's my denominator factor into?
T plus 2 and t plus 2.
Good. So what cancels?
T plus 2.
Good. So technically I have a 1 up there. I'm not going to show all of my steps, okay? And you'll see that I skip even more in here than I did in AB. We know we've got a 1 on the top. What's -2 and -2? -4. So -1/4. All right, we good with 13? Yeah? Okay. This one, there were some special limits that we had, and I'm assuming this is going to be one of those. Let's see. Oh, I know what I have to do. I want to make sure I get I can never remember the cosine. We only ever use the sine one usually. There it is. Okay, so there's 2 limits that we got to be careful of, and you have to make sure you have memorized. So the limit as x approaches 0 of sine x over x is equal to what? 1. Good. Then there was another one. This one we use more. Okay, not that we used it much, but we use it more. There was another one that was 1 minus cosine x over x, and that one equals 0. Okay. And it did, we learned on this one that it didn't matter if it was on top or on the bottom, okay? So you could have this, and it also equals not 0, but 1, okay? So the way I can I can't do what it's asking me to do because sine of 0 is 0, okay? But I could introduce an x over an x. So now what that gives me is the limit as x approaches 0 of 1 minus cosine x over x. So I put this x in that first denominator times x over sine x. We know that limit goes to 1. What does this limit go to? 0. So what is 1 times 0?
0.
That was a lot of work for a 0. We good? I definitely would make sure I knew at least this much of it, okay, and had that much of it memorized. And then the other way I play with that is we sometimes will put a number in there. Remember, if it's a 5x and a x, you have to make sure there's a 5 introduced on the top and the bottom. Okay, so the limit as x approaches 0. This piece here, the 5x and the 5 would go to 1, and you'd be left with a 5. All right. We have to determine if the function is continuous. So basically you need to make sure that the right and the left-hand limits are equal, okay, to determine continuity. So the limit as x approaches, and what number are we going to approach? 2 from the left, and the limit as x approaches 2 from the right. What am I going to use for the left branch? Yeah, and for the right branch? Yeah. All right, so this is plug and chug, right? Plug the 2 in there. What do we get? 3. Okay. Plug a 2 into here. 4 minus 3 is 1. So is it continuous? Not continuous. Could we, if we didn't know how to do it that way, could we put in our calculators and graph it? Yeah, we could also just graph. I mean, those are 2 lines. We should be able to graph the 2 lines, right, without the calculator. All right. Determine. Oh, it said determine what intervals it is continuous. We might not have answered that right. So we know that it's continuous when it is basically when it is not what number? 2. So it's continuous because they're lines, right? Lines are continuous everywhere except x equals 2. Okay, I'm gonna keep going. What do we know? Okay, remember there were 2 things we learned last year. If we cancels, it's a whole, right? So if I had something like 3x times x plus 1, if this canceled, there'd be a whole at x equals 0. When it's left in the denominator, what is it? It's an asymptote. It's a vertical asymptote, right? So I take this and I set it equal to what? 0. Good. So x equals -1 is a vertical asymptote. So that would be the only place where it is not continuous. So I would probably say continuous, again, everywhere except x equals -1. We good? Okay. Find vertical asymptotes, if any. All right, so for vertical asymptotes, wouldn't we want to set the denominator equal to 0? So where would our possible vertical asymptote be on this one? X equals 0. Okay, so basically you take your denominator, set it equal to 0, so your vertical asymptote at x equals 0. There isn't any really work to it. Sorry. Notice we haven't done any limits. It's all asymptotes right now, huh? All right. Oh, here's another limit. One-sided limit. Okay. And here's the problem with this one. If I put in a 1, okay, what am I going to get? 0. Okay, so what I really need to do is I need to figure out what's going on. And this one would probably be better with our calculators. Does this thing up here factor at all? Not anything that helps us, right? It's not going to come out to be a -1, is it? So there's a couple of ways I could do it. You could use your calculator and graph it and look at the graph. That's probably where I would go first, but we don't have our calculators out today. Actually, we could do this on the calculator. Let's play with something since we have the Chromebooks out. There is a good, let me show you where there's a good calculator on your Chromebook, okay? So in your browser, somewhere in there, type in Desmos. We'll see if we can get it graphed on Desmos and look at it that way. We would rather use our Inspires, but Mrs. Ballard hasn't set that up yet. All right. This would at least get us a picture, and just hit start graphing. All right, let's see. I'd probably use parentheses, so you have to kind of type it in. Parentheses, X, and then use the little caret key, which is above the 6, squared. See how it started to graph it? Plus 2x plus 1, and I'm going to close the parentheses and hit a slash for divide, and that put the divide on there, x minus 1. Desmos. There we go. That was a nice picture. That was better than trying to do it with decimals. All right, and I just zoomed out a little bit. Fraction. Hit the slash next to the shift button. Is there a slash next to it? It's the divide key. Yeah. Okay. I don't know if I can. Can I grab that so I can cut? No, I know what I can do though. Oh, this one isn't the new word, is it? No, our new one. Never mind. I can just hit print screen. Maybe. It's probably more trouble than it's worth. Okay. It is scaled by ones. It's kind of out every 5. So if we're looking at, I wanted the one-sided limit at x equals 1. So we're looking at x equals 1. What's at 1 on this thing? It's an asymptote, okay? So, because it's something that's left in the denominator, right? So we used a couple of tools to determine that. I could have also done a table or a t-chart and put numbers on there, but that's probably way more trouble than it's worth. All right, so this is, we would say it has a vertical asymptote at x equals 1. So the limit, so actually this limit would just be, it does not exist, right? Because there is a vertical asymptote there. Actually, it was going, what direction was it going, negative or positive? Yeah, when they did one-sided limits, didn't we normally do to negative infinity or positive infinity? So as we're going down from this side here, approaching, we're going to negative infinity. So probably negative infinity is a better answer than does not exist. So let's fix that. We'll go negative infinity. Okay, which you'd probably want the graph for anyways. Okay. All right. Looking at number 5, we're supposed to describe values at which it is differentiable. Okay, so probably describing it the opposite way is almost just as good. Where are the places that it's not differentiable? Why at -1? It's a sharp turn, right? There's four things, right? There's the corner, the cusp, that one's a cusp, right? And then there's oscillating, that's the way I draw oscillating. Which is typically a trig function, right? It's a funky trig function where it just bounces up and down all over the place. And then the last one is a jump, which kind of with this, the asymptotes on there kind of helps with that too. It's not differentiable at those. So this one is differentiable everywhere except x equals -1. All right, we go with 5. All right, let's look at 6. Oh, not 6, 7. All right. You may or may not have had any graphing absolute values because a lot of you guys skipped advanced algebra 2 or skipped algebra 2, and that's where it's taught typically. So do we know what that picture looks like? It's a V, right? Absolute value. It makes a V graph. Okay, and let me really quickly show you. I'm going to rewrite this a little bit. If I wrote it as negative absolute value of 2 plus 4. Remember when we had this? When we did and it was usually squared, it was a parabola. Okay, and we wrote the vertex, and some of you had me for that class, okay? Even if you didn't have me last year, you had me for that class. So we wrote it in, it's basically the same thing. When it comes in or out of this, what do we do to the sign? Change it. So our vertex is at 2, 4. Is it right side up or upside down? Upside down. Okay, and really what you can do off of here is count the slope. It's technically a slope of 1 because the V's kind of make lines. If it was a 2, we'd do a slope of 2. All right, so here I'm going to graph it. 1, 2, 1, 2, 3, 4. Okay. And then we said a slope of down 1 over 1, so it's going to do this kind of thing. And it's going to be upside down. So that's the picture. And sometimes just being brave enough, it says actually to sketch it, so we were supposed to sketch it. Now answer the questions. Is it continuous at x equals 2?
Yes.
Yeah, it's continuous. It keeps going, right? But is it differentiable? No. Why is it not differentiable?
It's not smooth.
It's not smooth. It's a corner, right? So not differentiable. You could put that it's not smooth, that it's a corner. Okay. It's a sharp point. One of those things. Maybe make a sentence instead of just 3 words that Mrs. Ballard didn't even write all of them. All right, number 9. Find the slope of the tangent line to the graph of the function at the given point. Okay, so this is way too easy, isn't it? Because we got to do a derivative, don't we?
Yeah.
Right, so what 2 things do we need to write a tangent line? Slope and point. Okay, the 2 things. We have the point. What are we missing? Slope. How do we get slope? Take the derivative. Okay, we're going to take this and multiply by the front. So what do you get in the front?
4/3.
X. Okay, and then the derivative of this thing here is? What if I rewrote it like this? What's its derivative? Negative what? 1 over 6, right? Because the x goes away. You subtract 1 off the 1 and it becomes 0. So it goes away. All right, what do I have to do to still get the slope? What do I have to plug in? Negative 1. So 4/3 times negative 1 minus 1/6. So what does this become here? Negative 4/3 minus 1/6. I'd probably, Kaylee was already going there. 8/6, right? So what's your slope? Which is really what? Do I have to simplify? No. Okay. All right, point slope form. Y minus what? Equals what's your slope? Times x minus negative 1. I don't simplify it anymore. You might have to a multiple choice test, but I may even be that nice and leave it like that. We'll see. All right, are we good? Yeah? All right. Find an equation of the tangent line of the graph of f at the given point. Use graphing utility to graph the function and its tangent line at the point. Use your derivative feature, the graphic. Oh, we don't. Okay, so I'm not worried about part C. Equation of tangent line at a given point. So what do I have to do first? Slope. How do I get the slope? Derivative. All right, what's the derivative of x cubed minus 1? Okay, doesn't get much easier than that. How do I actually get the value of the derivative? Plug in -1. What do I get when I plug in -1? 3. Okay, so and then I put it in point slope, so y minus what? Equals x minus -1. Plus 1's fine. I'm not worried about parts B or C right now. As long as this is way important, right? That you can get that equation of the tangent line. All right, I don't want to hear any of us going into the test this year 2 nights before asking anyone how do you get the equation of a tangent line. Okay, so let's make sure we know how to do that. All right, we good with 11? All right. Derivative. What do I want to do first with those guys? Yeah, make them into exponents, right? So x to the 1/2 plus 3x to the what? 1/3. Perfect. Okay, so now we bring them in front and subtract 1, right? So we're going to take that derivative. We put our little prime mark there to show we're doing that. What's 1/2 times 6? X to the -1/2. And then plus 3 times 1/3. 1 x to the, yeah, I'd likely leave it like that. Okay, they might do this to it. I could see them doing this because that exponent's negative, but they probably would leave this one upstairs because it's not a radical and not just a square. So either one is fine. Okay, I don't want to go too fast. Am I going too fast, or are we doing okay? All right. Oh, good. Sine and cosine. We need to make sure we know those derivatives. So, f prime of theta equals 3 is going to stay. What's the derivative of cosine? Negative sine theta. If you don't have it memorized, you need to rememorize it. What's the derivative of sine? Cosine. And it's really just a 1/4, isn't it? Done. Pretty basic. That one's pretty basic, even though they're both. I'd like that they're both in the same problem. Okay. All right. Somebody asked me about this one over the summer. This is the one we were working on, wasn't it, Nayeli? Yeah. Okay. So to estimate height of a building, this one's weird. A weight is dropped from the top of the building into a pool at ground level. How high is the building if the splash is seen 9.2 seconds after the weight is dropped? Okay. Let me see if I was supposed to look at this one ahead of time and I didn't. This is chapter 2's probably. And there is a funky equation that they don't give us. Okay. So the position equation due to gravity, and it's in the book somewhere, they just didn't give it to us in the review part of the chapter, is this. And that means the initial height. Okay? So what they want me to do is, first of all, we need to know how high the building is if the splash is seen 9.2 seconds after the weight is dropped. It really isn't any calculus, okay? What is the height at splashdown? 0. The height is 0, okay? So what I need to do is I need to plug in 9.2 into the time. So S of 9.2 equals -16 times 9.2 squared plus the initial value. And I'm going to set that equal to 0 and solve for it. All right, you can use your phones if you need to. Help me with the number, okay? So figure out what this number is. It's negative something. 1354 point what? 24. Is there anything after the 24? No? Okay. Remember, we always do 3 decimal places. Have to have 3 decimal place accuracy. That's a 5. So I'm going to move that to the other side. So we would say 1354.24, and it is in... does it give me a measurement for the... It should be feet. Okay. They rounded to 54. They didn't give us the 0.24. So. All right. That's the amount that I have copied and pasted over. That's where I stopped. So I could look up. Let's see what the next one looks like. 159.41. That's as far as I got on my prep. So, chapter 2, 154. Okay. All right, and this one should be page 150, not 154, 159 is where we're at. And it is number 41 was the next one on the list. Okay, find the derivative of the function, and the function is f of x. This one's nice. Okay. 3x squared plus 7 times x squared minus 2x plus 3. All right. There are two ways we could do this. Could I multiply that all out?
Yes.
Yeah, it said the instructions say find the derivative. Okay? I could multiply it all out. But probably what is it better set up for? What rule? Product rule. Your choice, okay? I'm not going to make you simplify it, so we might as well do the product rule. Okay, so product rule says keep the first. What's the derivative of the second?
X minus 2.
Close. 2x minus 2. Okay, then plus, keep the second. What's the derivative of the first? 6x. Again, you got to go by what's on the multiple choice, right? It might just have that. It might FOIL. It might multiply it out more. It just depends. I try to not do that to you, but sometimes it happens. Okay? Sometimes I miss catching one. All right, 159 again. 159. It says number 45 is next. All right, 45 is also find the derivative. That was the product rule. What do you think's coming next? Probably the quotient rule. X squared plus x minus 1 over x squared minus 1. All right, so let's just practice the quotient rule with that one. What's the quotient rule? Low d high minus high d low, right? Over low squared. All right, so low derivative high is what?
2x plus
Good. Minus the high, which is the x squared plus x minus 1. Derivative low is 2x. The nice thing about product rule is we can mess up the order. Here we can't mess up the order. All over the low squared. And that's where I would probably leave it. Okay? It's possible you might have to simplify more, but I try to avoid that. Okay? All right. 51 is also find the derivative. So 159, number 51, is y equals 3x squared secant x. All right, what rule are we going to need? Product rule again. So y prime equals, keep the first. What's the derivative of secant? Do we remember? No. Secant x, tangent x. Apparently we have. Apparently that one should go on Friday's quiz, huh?
No.
Yes, because we need to have it memorized. All right. Do we see it that often? No. Sine and cosine come up a lot more. Derivative tangent comes up a lot more. But secant's kind of the fourth one in line that'll show up. Cosecant and cotangent, for some reason, they don't use very often. Yeah. All right. Plus, okay, so that was keep the first, derivative of the second. Keep the second. What's the derivative of the first? And I'd probably throw that in front. They could. So here's something they like to do to you. Let me show you, okay? Because this could happen on an AP test. It could happen in here on a test. They like to take out the GCF. What's the GCF of this thing?
3x.
Is that it?
Secant.
Secant x. Yep, they might do this. So this would be x tangent x. And this would be 2, right? They could make that the answer. They love doing that in this book. I don't know why this author likes that, but they do. Especially in the test generator, they like that. All right. 55 is the next problem. So page 159, number 55. Okay. We're supposed to find equation of tangent line to graph at the given point. So f of x equals 2x cubed minus 1 over x squared, and the point is 1, 1. All right, so what do I have to do to find the derivative? Quotient rule. Okay, so what is my low?
X squared.
Derivative high.
6x squared.
Minus the high, which is... What's the derivative low? 2x over the low squared. And in this case, I wouldn't simplify. I just plug that number in because the number is going to be easier to deal with than the algebra. Okay, so what's 1 squared? 1. 1 squared times 6. 6. Let's see. That's going to be 2 minus 1, which is 1. 2 times 1 is 2. All over 1, right? So let's see. 6 minus 2 is what? 4 is your slope. So we go point slope y minus what? Equals what's your slope? 4. Times x minus 1. All right, we good? Okay. The next one's still page 159. Lots of derivatives. It is, what number did we just do? 55, so this is 61. Find the second derivative. So second derivative is what we're going for. So g of t equals t cubed minus 3t plus 2. G prime equals, so what's my first derivative?
3t squared minus 3.
Okay, and g double prime equals
6.
And remember, we always want to think of things, this is what, the position, the velocity, the acceleration. What's the third derivative, do we remember?
Speed.
Speed is the absolute value of velocity.
Oh.
The third one is called the jerk. You know how you hit the brake, and when mom's driving the car, she hits the brake and you jerk back? That's the third derivative. In action.
She hits the brakes and she
When she hits the brakes, you go forward.
I know, but that's the jerk, right? You jerk in the car. Yeah.
Second, I was like, no.
Yeah. Okay. And the soccer and the arm comes out, right? It's gonna protect you apparently. And mine all sit in the back seat still, so my arm doesn't come out as much as other moms still. All right. The next one says what?
I do that to my food. When I have food.
Oh, you need food.
I did it to my friend.
All right, the derivative is what we're looking for. So y equals 3 cosine 3x plus 1. All right, so y prime equals, what rule are we going to need here? The chain rule, good. Okay, because it's a function inside of a function. All right, so we got 3. So what's my outermost function? Cosine. Derivative cosine is? Sine, leave the junk inside. Okay. Then we've got the inside. So this one is a plain M&M, right? Yeah, if you weren't in my class, you didn't get the M&M lesson. Sorry.
Is it negative?
All right. Yes, it's a negative sign. Thank you. All right, and then the derivative of the inside is what?
3.
3. So if I could clean that up, it would look prettier as negative 9 sine 3x plus 1. Okay. The next one is problem 71. That was problem 71. Sorry, 79. Derivative of the function at the given point. So it's derivative function at given point. Alright, so it's f of x equals the square root of 1 minus x cubed, and the point is negative 2, 3. What am I going to convert that into first? Exponent first, so to the 1/2 power. Alright, I'm going to take my derivative. What rule am I going to need? Chain rule again. This is going to go in front. Leave this mess alone to the what power? And then chain rule gives me what? Okay, in this case, because of the negative exponent, I probably would simplify it because it's going to be easier on me. So I have the negative 3x squared up top, 2 in the bottom, and it's going to be square root of 1 minus x cubed. Now what number are we going to plug in? Negative 2. So what's negative 2 squared? 4. And then negative 2 cubed is going to be what? So we've got negative 12 over 2 times what, 3? So 6 goes into negative 12 how many times? Negative 2? What are we doing? We still got time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 28. All right. All right, I think we're going to stop there for today. How's that sound? Okay. So, remember this week you still have homework, right? Okay, you have 3 out of the 4 assignments, right? The 4th one is posted on Haiku. Okay? And then there's still a 5th assignment. I will try to have the 5th one ready for tomorrow. Okay, I'll make sure that that's up in Haiku for tomorrow, so you know what that is. There's 4, yeah. So there was a little half sheet one too. Did I not give you the half sheet one? Sorry. There's no. If you have your parent's signature on your syllabus, you can give that directly to me. I'll try not to lose it. The summer work I'll look at if you just want to show that.